So students, actually, Assalamu alaikum. I'm going to do one more problem on the inductor. So the problem is to determine the voltage and power. Okay, we have a circuit like this. Example. The example is example 6. Okay. So we have a circuit given like this. We have a current source I. Okay. Then you have an inductance of 100 millihenry. Okay. And you have a voltage given like this, plus minus V. Okay. And the current is given as I equal to 0, I equal to 0 for t less than 0, and I equal to 10t e raised to minus 5t ampere when time is greater than 0, t greater than 0. Okay. So what you have to do is you have to find out what is the voltage, right? The current is given. First you will find out the voltage, right? The voltage V is given by L di by dt, isn't it? So you know L is 100 milliampere, that is 100 into 10 raised to minus 3 di by dt, right? You have to do the differentiation by parts. First you will do the differentiation for 10t, then you will get it as 10 e raised to minus 5t. Then you will do it for the other part, that is minus 50, right? Minus 50t e raised to minus 5t, this much volts, right? So you will get it as e raised to minus 5t, right? Then this is 0.1 into 50 is minus 5t e raised to minus 5t. This is the answer for the voltage when t greater than 0. And obviously since I is 0 before this thing, you can write it as 0 volt for t less than 0, right? That's how you do the voltage. And what about the power? What you will do about the power in this case? You have to find out the power, find power, right? So what's the equation for the power that we have developed? Power is V into I. You can write it as V into I, right? So since you know V into I, you can write V equal to V into I, right? So you can multiply both. Okay. I is 10t raised to minus 5t and V is e raised to minus 5t minus 5t raised to minus 5t, right? E raised to minus 5t minus 5t e raised to minus 5t into current. What's the current? See the current. Current is given by 10t e raised to minus 5t into 10t e raised to minus 5t, isn't it? So you can multiply both sides. So then you will get it as 10t e raised to minus 10t, isn't it? 10t raised to minus 10t minus 50 t square e raised to minus 10t. That's the watts, right? That's the power equation. Understand? So you can take out 10t raised to minus 10t is common. You can take it as represent it like 10t e raised to minus e raised to minus 10t into 1 minus 5t. Like this also you can write the answer. Both are same. Okay. That's how you will find out the power. And what about the energy? Energy is integral P dt, right? You can write this integral P dt. If you want to find out energy, you can write the integral 0 to T P dt, isn't it? If you integrate this thing, then you can find out the energy also. So you can do the integration by parts as I have done in the earlier problem. I am not going into the details of that thing. Okay. So now we will move on to a new topic. Try to complete this problem. This is very simple. You do the integration by parts that I have explained in the previous lecture. So suppose we will see what will happen to inductances in series. Inductors in series. Okay. Just like this. You have an inductance L1 which is in series with an inductance L2 which is in series with an inductance L3 and so on, right? And it is going on like this. You have an inductance Ln and all of these are seriously connected in series. Okay, you have inductances like this connected in series, and you have made a voltage plus or minus V here. Okay, and you have a current I going inside. You can always see that this is easily derivable. L equivalent equal to L1 plus L2 plus L3 plus go on like that Ln, right? So the same circuit we can represent like this. It's a same thing like what you have for a resistor. Resistors in series you add up, right? So this is L equivalent. Understand? Both are same. That's how you have inductors in series, right? For example, if you have two inductances of 15 millihenry and 3 millihenry, right? Understand? This is equal to a single inductance of 18 millihenry. Both are same. Okay. So that's how you will have the inductors in series. And if you go for inductances in parallel, you can see that you have many inductances L1, L2, like that. You have n inductances in parallel. This is plus or minus V input voltage you are giving, and you are giving a current I here. Okay. So here also the rule is the same as that for a resistance. So inductance series and parallel is the combination is same as right of resistance. You can represent this by a single equivalent resistance 1 by L equivalent equal to 1 by L1 plus 1 by L2 plus 1 by L3 plus like that 1 by Ln. Okay, understand? So this is equal to a same. Okay, we have an equivalent plus or minus V and the current I going in here like this. Both are same. Okay. So you can write L equivalent equal to 1 by L1 plus 1 by L2 plus through like that 1 by Ln. That's a rule for the inductors in L. Suppose if you have only two inductances, it is very simple to write it. If you have only two inductances, L1, L2, okay, right? Then you can write Leq for in this case as L1 L2 divided by L1 plus L2. The same two inductances. This is the same rule that you have for the resistors also, right? So that's how you will have the inductors in parallel. Okay, and we will do a simple problem. So you have a inductance here that is maybe 4 Henry and maybe another inductance here that is 8 Henry. Okay, so it is equivalent to, you have 4 into 8 divided by 4 plus 8, right? That is 32 divided by 12, right? Henry. So this is equivalent to a single inductance of 32 by 12 Henry, right? That's the answer. Now these are the inductors in series and parallel, right? Now we will do a bit more complicated problem. Example we will do. You have many inductances like this. There's a 4 Henry here. There is a 7 Henry here. This is 7 Henry. Then you have 8 Henry here. Then you have a 20 Henry. 20 Henry here. Again a 12 Henry. 12 Henry. Then you have a 10 Henry here. Yeah. So you have to find out the equivalent from this terminal. You have to find out the equivalent from this terminal. So you can see that 20, 12 and 10 are in series. So you can write as a 4 Henry, then 7 Henry, 8 Henry, then 20 plus 12 plus 10, that is in series. So you connect it in parallel here like this. 20 plus 12 is 32. So that is 42, right? So you have 42 Henry here. So now this 42 and 7 are in parallel. So you can write it as 42 into 7 divided by 42 plus 7. How much is it? 42 into 7 divided by 42 plus 7. You have to calculate it using a calculator. Okay, calculator, you take the calculator. So you have, I will do the calculation here. 42 into 7 equal to, divided by 42 plus 7 is 49, isn't it? So it will come as 6. So it will be equal to 6 Henry. 6 Henry. So this you can write like this. You have 4 Henry here, then another 6 Henry here, and another 8 Henry here, right? So these three are in series. So you can say that it is, and so the 4 plus 6 is 10 plus 18 Henry, right? So you will have something like 18 Henry here. So that's the total equivalent inductance. Okay. Now, if you want, you can do one more problem. Another example. Okay. Here it's a bigger one. You can do 20 millihenry, right? 100 millihenry. Then 40 millihenry. Then 20 millihenry. Then this is 30 millihenry. 40 millihenry. 50 millihenry, right? So first you find out the series of 40 and 20, that will be 60, right? So it will get it as, you can get it as 20, 100, 100, yes, 50, 40, 30, then this is 60, all are millihenry, right? Now in the next step, 30 and 60 in parallel, you find out 30 into 60 divided by 30 plus 60, that is 18,800 by 90, that is 20, right? So you can write it like this. Fifty, 40, 20, 100, okay, 30 and this is 20, okay. Again, you can reduce it. Okay. You can reduce it like this. Again do. will be 30, equal to 30. So we will have this as 20, 50, and this is 30, right? Now again 40 and 50, so it will be, we have 50, we have 40, right? Now what is 40 and 50 in parallel? We find out 40 into 50 parallel. 40 into 50 divided by 40 plus 50 is 90, isn't it? So it will be 22 point, okay, you can write 40 into 50 divided by 40 plus 50 equal to 22.22. So the last equivalent will be 22.22 millihenry. That's the answer. Okay. That's how you will do the problems for the series case. Okay. So there's a bigger example. Another example given. Another example given here. You have a circuit like this here. Given inductance, another inductance, and also another inductance is given like this. This is 12 Henry, and you have a current I2 going here, and the current I1 is going here like this. Okay, current I1 going, and this is 2 Henry, this is 4 Henry, and we have voltage plus or minus V here. Okay, then the voltage in between this point and this point is given by V2, and this voltage is V1. Okay, so what, find L equivalent. First question is find L equivalent inductance. Okay, so first for finding L equivalent, what we do is we can draw the circuit. This is 2 Henry, and you have 4 and 12 coming in parallel, right? So you can find out the equivalent inductance as 4 into 12 divided by 4 plus 12. 48 by 16 is 3 Henry, right? So you have 2 Henry and 3 Henry in series. So L equivalent will be equal to 2 plus 3 equal to 5 Henry. That's equivalent inductance. Now what is VT? VT, you have to find VT. Second question is VT. What is VT? Okay. You know VT is given by L equivalent into DI. This is a current I is going inside here. LDI by dt. And for this problem, we have been given I is given as 4 into 2 minus e raised to minus 10t milliampere. That's the value of I. Okay. 4 into 2 minus e raised to minus. Okay. So you can write it as 5 into di by dt. 4 into 2 is 8, so that is 0, right? 0 minus, right, minus of minus is plus, that is plus 40 e raised to minus 10t. Okay, milliampere, so you have to write it as into 10 raised to minus 3. Okay, so it will come to be 200 e raised to minus 10t millivolt. That's the value of Vt, right? Now the next is what is the value of V1t? V1t, you see, in V1 you have the same current I flowing, right? So you can write it as 2 di by dt, that is 2 into same thing, di by dt is 0, right, minus plus 40 e raised to minus 10t into 10 raised to minus 3 because of the milliampere, right? That will be 80 e raised to minus 10t millivolt. That's how you will get V1t. If you are asked to find out what is V2, V2 is actually, V2 is, you can say that V2 T equal to V minus V1t using the Kirchhoff's law, right? V minus V1t is V2t, right? So you can write what is V. V already obtained as V is obtained as 200 e raised to minus 10t, right? 200 e raised to minus 10t. So that is 200 e raised to minus 10t minus 80 e raised to minus 20 millivolt. So it will be 120 e raised to minus 20 millivolt. That will be V2t. That's how you will do this problem. Okay. So with that, actually, we will stop the lecture on the inductance.